Awesome. We have Jeremy Howard here. I really don't think he needs an introduction. He's a famous person, a celebrity in the AI space, having done a lot of cool technical work, including the one with Sebastian Ruder back in. I don't hear you, or is it on my side? Or
yeah, I did the work for it in 2017 and wrote it up in 2018.
Awesome. And then fast.ai courses, which I think a lot of people here might be familiar with, I guess. And finally, you recently started the answer.ai startup. You raised $10 million. So I think we might start with that, because I know there's a lot of questions on that topic, just startups in general, and in particular, people are really interested about what answer.ai is doing. So maybe we can start by just you telling us a bit more what's answer.ai, like what's the idea here. Hey guys, I want to give a huge shout out to Hyperstack folks who have generously sponsored my compute over the past month or so. Basically, I got 16 H100s, which is 2 8 GPU nodes, and the performance has been amazing, basically 2x the speed up compared to my A100 nodes. So I want to quickly show you how you can get started yourself. It takes basically 3 steps only. You go to the environments here, you create a new environment, you give it a name, you pick between Canada and Norway. That's the first step. The second step, you go to SSH keys here, you create a new pair, you pick environment you just created, you give it a name, you paste your public SSH key. That's it. And finally, go to virtual machines, deploy new machine, give it a name again, select environment. Let's select Canada here because they have more compute there. Then you select the hardware you want, like for example H100s. You select the images, you select the SSH key you just created, and hit deploy. That's it. Literally a couple of minutes to get started. It was really easy for me to just basically create these 2 nodes I just mentioned and get started running LLM trainings. So the documentation is super cool. I could actually solve all of my problems just by looking at their docs. They additionally have a Slack channel where they were super helpful, so I can't recommend them enough, honestly. The thing they kind of focus on is basically, because a lot of these GPU providers focus on big enterprises, so oftentimes you can't get on-demand H100s, whereas NextGen focuses particularly on that. You can get top-of-the-line hardware on demand, even if you're an individual or like a smaller team or whatnot. They also focus on bigger companies, but that's kind of their edge here. So without further ado, guys, let's go back to the talk. I do suggest you check them out, and let's continue.
Sure. So for the longer version of this, go to the URL, answer.ai, funnily enough, and there's a post there that describes the background and purpose and method and so forth. But in short, it's a R&D lab, which I have co-founded with Eric Rees. You might know Eric from his work in developing the lean startup. He developed the idea of the minimum viable product. He built the long-term stock exchange, amongst other things. We've been talking for years about our concerns about the direction that AI has been going. We felt that it didn't seem that clear that it was heading in a direction that was going to actually maximize the value of it to society. Everybody's very focused on building bigger and bigger language models, generating more and more money and burning them on more and more GPUs. We don't see a lot of people working on the more fundamental question of like, what's this good for and how can it help people? And what do we need to get from here to there? So eventually we thought, fine, we'll try and do it ourselves. It's quite challenging then to think how to do that, because it's not the kind of thing that you can do very easily in academia, because in academia, your currency is citations. So for those of you who work in academia, you'll understand very well this issue. In order to get citations, by far the best, easiest way to do it is to work on the same things that everybody else in your field is working on, measure them in the same ways that everybody else is measuring them, and make incremental improvements on methods that everybody recognizes effective. And that way your colleagues in that research space will be able to easily review your work, and it'll get published and it'll get cited, because other people will work on that same field and they'll say like, oh yes, as this paper mentioned, blah, blah, blah. This is pretty poor for, for the kind of R&D we're trying to do, where we're trying to say like, well, what kind of problems should we actually be working on, and how actually should they be measured, and like, maybe we should try totally different approaches. So it's a poor fit for academia. It's a poor fit for big tech, because big tech, like Google, Microsoft, OpenAI, nowadays especially, they have specific products, they have specific KPIs, they have to hit those metrics, they have, huge investors and shareholders and so forth. It's very hard for them to do more speculative work, particularly where it's saying like, maybe we should go in a different direction to how we've been going. You can see that with, for example, what Google did when they found themselves behind on commercialization of language models. Rather than think, oh, I wonder how we can go like to the next level, they literally spent a year and hundreds of people literally almost exactly replicating GPT-4. I mean, that's an impressive achievement, but it's not pushing the envelope in any way, It's also hard to do as a startup, because startups, you have to get investment, you have to show kind of product market fit. You have to say, this is what I'm building and who I'm building it for, and this is how much we think they'll be able to pay, and this is the size of the market, and so forth. So there hasn't been really an applied AI lab of this kind for many decades. They disappeared off the face of the earth. But there was a time where they were quite common. They became particularly popular after Thomas Edison created what he called the invention factory. And the reason that was created, I think, is really relevant to where we are today. So what I did is, as Eric and I were thinking about answer.ai, is I put myself in the shoes of Faraday. And I thought, what would it be like to be Faraday at the point where, they've figured out how to store and harness electricity. And so it's like, oh, okay, that's pretty cool. Now what? What does the world look like now that we can store and harness electricity? Answering that question is going to take, over 100 years, well over 100 years. It's difficult. And so Edison, for all his faults, of which there are many, recognized the world will look fundamentally different now that we've harnessed electricity. And the way to figure out how it can look different is to bring together the world's best, engineers and scientists who could understand this field, and have them work really closely together to try to build useful things that use electricity. And so they ended up building a lot of useful things, and some of them were easy to recognize that they were things one would want to build. For example, the lamp. We already knew that converting energy into light was a good idea. We did it widely. We knew it was inefficient and annoying the way it was being done. So that was really purely an engineering challenge to come up with a way of doing that with electricity. Some were much less obvious, like electricity can be used to create rotational motion. Okay, well, that's pretty straightforward. You could then use that if you had little hits on a rotating disk, those that can be converted into magnetic signals that can be then used to move a sheet of something thin that could create sound. Oh, now we've created the phonograph. So things like the record player or the refrigerator, we could use electricity, compressed gas to make things cold. These are like non-obvious. To be honest, I think this is where we're at right now. If you ask like, well, what are language models good for, to anybody that really studies language models a lot, I've asked this question of many people in the world's top research labs, in the world's top industrial centers, the top startups. Nobody says that they know the answer to this question. I don't know the answer to this question.
I might have like an input here on my side. Like, I mean,
Yeah.
I don't know about how you use language models right now, but like for me, for example, coding assistants have definitely changed the way I do work. So that's one big application that's super useful. Then the second one, I really oftentimes use ChatGPT. For example, recently I went through some legal stuff, just like it changes the way I search web. So like from that standpoint, it is I'm not sure whether we are saying then the same thing, but like, are you arguing that there is still a lot to be discovered, or are you saying that LLMs
these are
in its
like
current
very
format are not
incremental.
that useful? Because I know
No, obviously this is useful, but it's like the electric lamp. I mean, the electric lamp's useful, but we okay, yeah. I mean, it kind of OpenAI kind of accidentally discovered that LLM-enabled chat is really useful. With Codex, we discovered LLM-enabled coding assistants are useful, but it's not world-changing yet, right? Like, what are all the I would guess that AI is going to be vastly more important than those two things. And I would say we're at the point of like having, figured out the light bulb, but we haven't yet figured out, the computer, the hi-fi, the telephone, et cetera, et cetera. We're just starting to see how to like incrementally improve things we already understand very well. So to figure out like, the record player, or to figure out the refrigerator, the equivalent of those for AI, actually is going to require a lot of work. And it's going to require people who deeply understand at a kind of a deep intuitive foundational level what language models actually do, how do they actually work, what are they actually good at, what are they actually not good at. So yeah, so that's why we created this R&D lab, which is like this is what we study. So we try to figure out what are the things we think it could be good for that are maybe a little less obvious, and then what are the research insights we need to get to a point where that's going to work really well, and then try these things out, and by doing this again and again and again lots of times with an extremely small group of people, extremely small group of like very, very technically deep generalists, what could we create, and so we're hoping what we'll end up with, if the thesis is correct, which is that AI is actually going to be extremely useful across an extremely large number of fields, we hope we'll end up with the world's most valuable and successful company, and that it'll be tiny. Why do we need hundreds of people if we think we can automate a lot of stuff? So we expect to have a really small number of super deep people. And with this kind of, yeah,
I would just comment, we're definitely seeing that trend across like indiepreneurs being able to, like, smaller and smaller teams being able to build bigger and bigger things, and then the trend kind of continues over the last years. But
yeah, and even without AI, I've done it before, So at Fastmail, which was the first consumer email company to provide synchronized email across your devices, we decided to stay small, and we went all the way up to 1 million accounts with just 3 people. And so every time there was another like scaling issue, and this was before there were any web frameworks, before there was any PagerDuty, before there was any Twilio, before there was, any of the things we today rely on. We had to build them all ourselves, or the equivalents, and we did just by deciding to automate things. So we think you could go a lot further now with AI. So if you look at like Instagram, if you look at like WhatsApp, these are all kind of pre-AI companies which created billion-dollar companies with like 20 or so people. So we already know you can do a lot whilst being ruthlessly small. We're curious to figure out like, okay, like, can we go 100 times bigger, without increasing that kind of size?
That's super cool. A couple of questions that people had, which are related to this, obviously, is first, which projects do you currently have? And then related, are you currently hiring? You mentioned super small team. That might be a bit discouraging to some people listening to this who might be willing to apply. But if you can tell us more about like, how can people apply? And yeah, are you hiring? Stuff like that.
Sure. So our initial projects are, so my thesis is that the research world is underemphasizing fine-tuning and continued pre-training, particularly on lower resource hardware. We think there's a lot you can do with like higher levels of personalization, dramatically decreasing the costs of these things, and opening up whole new application areas by being able to do low resource fine-tuning and continued pre-training. So at the moment, it's a bit of a focus. We have just gotten FSDP LoRa working for the first time, so we'll be starting to release that over the coming weeks. So you'll be able to, and so we've been working with Tim Detmers and some of the folks working with him on making that happen. So you'll be able to train larger models on like 23090s, for instance. We think with this kind of stuff, it really makes fine-tuning a lot more accessible, and we'll be releasing all this as open source, of course. It's very early days, but we're very interested in building that kind of stack on Mojo as well, so not just on Python, because we think that's where we're going to get much better performance and much better hackability. So there's examples of a couple of the early projects we're working on. Hiring, yeah, it's hard around hiring because we want a small team, but we want a great team. So obviously we just have to hire slowly and carefully. So yeah, if there are folks watching this who feel like they can, are interested in doing everything from debugging FSDP network problems and CUDA kernels up to thinking about, end user product features and joining them everything in between. Or if you've been doing some really interesting kind of language model type research and stuff and feel like you've got ideas about how to build cool applications on that and stuff, yeah, please do reach out. We're very keen to chat to people. And even if it's not for a job, a lot of our work we're going to be doing through collaborating with academic research labs. So if you're in an academic research lab, like doing a PhD or something and want help, trying to make sure your PhD is actually going to make a significant societal impact rather than just incrementally push one little bit of knowledge outwards. Again, that's something we'd love to chat to you about.
Super cool. One quick question on my side is, like, if I get it correctly, you are for profit, but I'm just trying to see how do you manage the obviously the investor pressure that's going to eventually come into the play with this very R&D type of researchy.
No, that's exactly the great question, Aleksa. So I mentioned that startups are not a good fit for this in a lot of ways, and yet we are in fact a startup. We are in fact for profit. So the trick is that my co-founder, Eric Ries, as I mentioned, he created this thing called the long-term stock exchange. The thing he's been working on for decades is trying to think about how to create organizations like this. Organizations which are looking to create long-term value, but work within the for-profit capitalist system that we have. OpenAI tried to do things a bit differently. They kind of tried to almost like work against it by saying like, oh, we'll be a non-profit with a kind of for-profit subsidiary. And in the end, that kind of thing can be a bit too confusing and a bit too complicated. And as we've seen, sometimes it can result in more problems than solutions. So Eric's view is, and the thing he's been working on is, you can actually create for-profit companies, but if the for-profit is for long-term profit, then you can define that in a way and calculate in a way where it is almost the same as measuring societal value. So, if somebody's like, oh, we could, invest in doing all this research into making more deadly drones, for example, and that's going to make a huge amount of money because this state organization is going to give us all this money for that. We're like, okay, from a short-term profit point of view, that's probably, the fiduciary responsibility says, yeah, you should do that. From a long-term profit point of view, okay, they're going to be killing people. Those people you're killing are going to be your customers. You're going to be helping create a less stable society, so there's going to be less of a market. You're going to be making everybody pissed off with you because you've helped push the world towards war, and so they're not going to buy your products in the future years. Like, it doesn't actually make sense. So, so the way we're set up is we have just set up actually a public benefit corporation, a PBC. So that means that our fiduciary responsibility is to our stated benefit, which is in our kind of our charter. The stated benefit is basically, in short, is help use and develop AI to benefit society, whilst making money. And then this requires a high level of patience on the behalf of the investors. And so rather than kind of trust in that, we've set up the corporate documents so that Eric and I will maintain the strategic control of the company going forwards, basically no matter what. So we want to make sure everybody's happy. We want to make sure the investors are happy. But in the end, if the patience isn't there after all, it doesn't actually matter. We can still keep pushing forwards with our mission over the next many years.
How do you make sure? I mean, we've seen, you mentioned OpenAI, which is a great example, and we've seen recent things that happened with Sam Altman getting ousted and then getting back to company. And then DeepMind was also started back in, if I'm not wrong here, 2009, when Demis and Sean started with the idea of building the AGI, and I guess I don't know their pitch back then, but I would guess AGI was so far away that it was much more, again, R&D type of a lab, and now they are acquired by Google, obviously, and all of that. Like, how do you see long term? What do you think is going to make you different in that respect? Because ultimately you will have to make money, and there's going to be a couple of you who have, as you said, strategic control, and like, I'm just trying to understand that a bit better.
Yeah, these are exactly the right questions to be asking. The big difference with OpenAI and DeepMind was that their mission was very different to ours, which is their mission was to create AGI. And so even when Rachel and I created fast.ai, and people would often ask us then, oh, are you guys trying to create AGI? We said, no, we're not. I mean, we might accidentally help create AGI because actually, doing research into how to make AI more accessible and creating courses to do that and creating software to do that, if AGI is going to be achieved, then those things will probably all help. And indeed, they did. At OpenAI, their Scholars program used the fast.ai courses to help people bring people into OpenAI, for example. But that was never our goal. And it's not at answer.ai either. Our view is that the right way to make AI beneficial to society is to specifically and precisely make that your goal. Doesn't matter whether or not we create AGI. We just want to make societally valuable products and services that harness AI. And so that's a pretty easy thing to keep focusing on because it's such a naturally obvious thing to want to do. And so if we've created 50 products and services that are societally beneficial, and you can see the benefit to society because people are prepared to pay you for them more than they cost to build. That's a very easy thing to keep doing. It makes commercial sense, and everybody feels good about it. And the more you do it, the better you get at it. So it feels to me like a really kind of like natural, comfortable way to run an R&D lab.
But then I could play a devil's advocate and ask, like OpenAI pushing for ChatGPT, and obviously people be willing to pay $20 for subscription and all of that. Everything they're doing is also creating obviously socially and economically useful products. And so, like, if I'm not putting you in an awkward spot, like, what would you say they should be doing better, or like?
No, not awkward at all. I mean, it's a great point. I think they've ended up in a somewhat similar spot to where we are, but they're not set up that way. So they're going to always be struggling with a number of issues. One is that they are a nonprofit, and their charter is to create AGI, specifically to create safe AGI. So they're always going to be in this difficult situation from a governance point of view, where the thing they're doing and the thing that they're meant to be doing are two different things. I think also because the thing that they are meant to be doing is different to the thing they are doing, and that they have a huge amount of investment from Microsoft to do the thing they are doing rather than the thing they're meant to be doing. They have a lot, they're burning money. They have a lot of technical debt, I think. I just don't think they're set up optimally to do the thing they're actually doing, and I don't think they've hired the kind of people who are really great at creating like end user products and experiences or enterprise services or any of those things. Like if you look at the chat GPT UX, nobody at OpenAI that I've chatted to thinks it's actually any good, because they haven't been working on being good at that. They've been working on something else. So I don't see OpenAI as a competitor. I see them as, I've got a lot of friends there. I think there's plenty of people there that are kind of like-minded spirits. But I think they're chasing after quite a different thing in quite a different way in the end. And they're also very focused on building the foundation models. And our view is actually that a large amount of the value comes from what you do after the foundation model's built. And so that's where we're focusing our effort. So there's actually a lot of good opportunities, for collaboration between answer.ai and OpenAI, because we are interested in different parts of that kind of value chain.
Makes sense. I'm just thinking about these complex objective functions, and here you were mentioning that OpenAI doesn't have the right goal to achieve what you're mentioning. But I'm just thinking LLM, like I'm going to make an analogy with LLMs, which might be bad, might be good, but like the idea was to do auto-completion, and all of a sudden you had the emergence of all of these properties. And then what happens if like OpenAI is trying to achieve this high level goal of doing like getting to AGI, but as a side effect, they create a ton of economically useful and socially useful products, and they just solve the economy, quote unquote, getting to the AGI. Like, could you foresee such a thing happening in a very complex landscape that they are optimizing?
Yes, absolutely.
Objective function being getting to AGI, like, which is very abstract.
Absolutely, and I hope they do. To be clear, like the world's a big place. It's a big market. There's going to be just like there's no one person that's monopolized every type of thing you can use electricity for. I just don't think there's going to be any one company that monopolizes every possible thing you can use AI for. So some of the spaces that we're particularly looking at the moment include the educational space and the legal space. We'll have the particular areas that we actually end up being pretty good at, and that's fine. A nice part of like caring about long-term value, and we specifically mentioned this in the launch post, is we don't have a moat and we're not trying to create one. Moats are used to keep people out. We don't want to keep people out. Like fast.ai's mission was literally to make AI as accessible as possible, and answer.ai's mission is pretty close to that as well. So we have absolutely no interest in building and maintaining moats. We're entirely interested in creating a big enough castle for everybody.
Got it. But it's a more of a philosophical stance, because ultimately you said you're for profit. But you did mention that this thing with Derek Rees that I don't remember the term you mentioned, but I'm still trying to see. I see a conflict in you will ultimately have to be earning money, and then the moat is, I guess, a necessary bit of getting there. Like,
yeah, I mean, a moat's only needed if you think that there's a fixed size market, and so the only way to get more of it is to keep other people out of it. But if we work to make that bigger and bigger, then why do you need a moat? Again, like if you think about how many people use electricity in how many ways, companies never need to try to stop other companies from effectively building stuff that use electricity. In fact, there's a great network effect when more people have access to electricity. So yeah, we don't at all see this as a zero-sum game, and we don't play it that way.
Yeah, it's definitely not a zero-sum game. I'm just like, I guess we have a different definition of what a moat means, but I understand what you're saying now. There are some questions people had like in general about startups. One of them was, how can a startup persevere in AI research without significant resources and connections in the industry? I guess this ties nicely to what you've been saying about trying to democratize AI and make it more efficient to run on like even two RTX 3090s or whatnot. How would you reply to this?
Yeah, I think, research is really difficult, and I decided as a young man not to go into academia because I just couldn't see a path to doing it in a way that the research that I was working on was actually going to make a big difference to the world, because I felt like I didn't know what I should research on, and I couldn't find any professors that knew what I should research on, because they were all focused on what's required to maximize citation counts. So I think so there are different kinds of research, right? But if you want to do research which maximizes societal value, or even just has a significant impact on societal value, I think you do need to be working closely with folks in industry. And so that's why I'm finding quite a few of the very, very strongest academic research labs are interested in working with us. And so, we can help direct and supervise their PhD students and collaborate together on papers and so forth, where they can help with their new ideas, their new academic ideas and the things that they're doing research on, and we can help with giving feedback about like, oh, that if you got that to work, that would make a big difference because you could use it in these ways, but it would only really help if you could do it in this, if you could also avoid this constraint, for example. So yeah, that's exactly the kind of collaborations we're building, and we do see that like this is not a new idea at all. Like I think there are some academic institutions that have been pretty good at this. So for example, Stanford quite often and Berkeley both quite often collaborate with folks at Google, for instance, and often those kinds of papers are particularly high impact. And so that, I think that kind of model is great for both the students and the companies involved.
Makes sense. I guess that's why you've been thinking so hard about a different model as well. And I think I'm similar in that respect. Like I realized early on, I don't want to go push. I don't want to play the game of just maximizing the H index. It's just like ends up oftentimes being very incremental and like and ultimately just a popularity game on Twitter as well. So like,
I mean, if as an academic, you're ever in a situation where people are saying, we have to hurry to publish this, otherwise we're going to get scooped for sure, then what are you doing? Like you're literally, somebody else is going to do the thing you're doing right now anyway. So by definition, you're wasting your time, like at least from an impact point of view. So like to me, and I don't hear people say this, to me, like the immediate response to that should be like, okay, this is not useful. Let's stop doing it. What can we do that not everybody's going to be doing in 3 months? And that's interesting.
Agreed. And I actually know a couple of really, I'm not going to name the names, but like a couple of really impactful research papers that were literally just a thing of who's going to publish first. And like, I don't think people realize, especially folks who just entered the field and look at the researchers as like gods oftentimes, especially if they have high H index or like main authors, first authors on some of those papers. They don't realize the dynamics that like if they didn't publish it in 3 months, somebody, or 2 months, somebody else would. So like they just were the first one to do it, but like, yeah.
Yeah, I mean, if you compare that to the ULM Fit paper, where like I asked lots of NLP researchers in the months before I did that, do you think, it would make sense to pre-train a large language model and then, on a general corpus and then fine-tune that for a range of different downstream tasks? And everybody said, no, there's no point doing that because it wouldn't work. And I thought, I have a feeling everyone's wrong, so I'm going to do it anyway. And so there was no chance of being scooped because everybody thought it was a stupid thing to do. It does require a certain amount of gumption to work on research that not everybody thinks is going to happen in 3 months anyway, but that's the way to actually do something meaningful, in my opinion.
100%. The thing is, it's high risk, high return game, right? Same as with startups. Like you could start something that's going to be like 1 to N, and you're fairly sure you can execute and get some money. But if you want to really shoot for something big, you have to risk. You have to like accept much bigger risk as well. They're very
and
similar.
this is where answer AI is a kind of a really interesting opportunity for the R&D folk who do end up working here. Is we have the time and space and money to take some bets that don't work out. So for an example of a bet that may or may not work out is investing in Mojo. I suspect Mojo is going to turn out to be the most significant and important language for AI, and possibly a hell lot more. But it might not be. There's lots of reasons it might not work out. Not least of which, like, oh, maybe Modular runs out of money and can't work on it anymore, or it's very much in Chris Lattner's brain. So maybe, I don't know, Chris Lattner gets bored of it and does something else, or whatever. Something might go wrong. And, at a normal startup, you can't do that. Like, you're especially if you've got a family or whatever, like it's all on the line. You've got to make something work. In academia, it's pretty similar as well. You've got to be consistently publishing. You've got to be consistently showing results, building up a lab, getting the grants. So I think it's nice to be in a situation where, look, we need to have wins, but not everything has to win. Like, and if when I think about potential projects we can do, if it's like, okay, this is 100% sure it's going to work, I think like, oh, well, are we the right people to be doing this? Because there's lots of people in the world who can work on stuff that are 100% sure are going to work. I'd quite like to work on stuff where we're not quite sure it's going to work, but we think if it does work, there's a reasonable chance, and if it does work, it could be hugely important. So, even like this FSTP QLoRa project we've been working on, I wasn't quite sure it was going to work. The way FSTP and QLoRa break when work together, it like literally just your GPU goes up to 100%. It's almost impossible to debug. I wasn't sure like if there was some fundamental underlying reason why this couldn't work or what, but we thought if we can get it to work, then suddenly now everybody with, who wants to scale up their training can chuck another 3090 or 4090 into their box and start training bigger models. Well, that would be kind of pretty cool. It's not going to change the world, but it's a nice incremental improvement, makes a higher level AI more accessible. I thought, yeah, that's a cool project for us to work on, and we're excited. We've now got it sorted, got it figured out.
Super cool. You mentioned Mojo. Can you maybe, somebody asked a question, if you can do a recap since it was announced, I think May last year. What are your thoughts a bit more on Mojo in general? You mentioned Chris Lattner and that you're really bullish on the project, but if you have any other thoughts.
Yeah, so Chris and I have been talking about this since literally the day he joined Google. I think it was that day, or about that day, because that was when the TensorFlow Dev Summit started, and we started talking about all the problems with using Python in this space, and also all the good things about using Python in this space, and what are we going to do about that? In the end, my disappointment as a researcher and as an educator in using Python and AI is its lack of hackability, by which I mean if you're using PyTorch or JAX or whatever, you start digging into the code, whether it be like stepping through in the debugger or just, looking through references in VS Code or whatever, and you hit this spot where it's like, oh, we're not in Python anymore. This is a pre-compiled symbol that does 1,000 things. I find this challenging, for running a profiler, for running a debugger, for educating, but also as a researcher, we see this all the time. I've seen this my whole career in machine learning and AI. Every research direction that requires like writing a new CUDA kernel is like 100 times less likely to get followed, because like far fewer people can do it. It takes far longer. It's much more likely that you'll screw it up. Nobody enjoys writing them. So this is what Chris and I have been talking for years about, like, how do we fix this? And so we've been trying to look at like, what would a better language for this look like? We had a failed attempt at doing this with especially for TensorFlow, which didn't have fundamental technical problems, but that was a political problem in that for Google to basically, make a bet on getting everybody to change to a different programming language was probably too hard for them to swallow. And so Mojo is, basically the next iteration of trying to figure this out. And I think there's a lot of improvements over what's gone before. The Python-like syntax makes it much easier to get started with. The ability to actually import the Python runtime itself means you can use all of the Python libraries. The fact that it targets MLIR means that you're actually running on top of an intermediate representation which was specifically designed for these kinds of algorithms, and you can then target a range of different backends. So yeah, I'm pretty excited about it, and hopefully in the next month or two, the first GPU-enabled builds will be appearing. And this is when the rubber really hit the road, right? We can start to really experiment, like, okay, what does it feel like to use a single language to write the kernel and the networking layer and the kind of, the driver and, everything. And I'm hopeful that's going to feel a whole lot better than trying to create a, the equivalent thing. Like if you try to create FSDP QLoRa from scratch in Python, for example, you're going to have to, like, literally from scratch, you're going to be having to, like, okay, I have to use C to write my networking layer. I have to use CUDA to write the quantization and model layer. I have to use Python to tie it all together. I have to then figure out all the overhead and latency of all this. Now to make it run fast, I'm going to have to do some kind of torch.compile thing anyway to fuse it, otherwise it'll be slow. It's complicated and unpleasant.
Interesting to see different incarnations of the hardware lottery also in the space of programming languages. Same as with GPUs preferring certain architectures. The same thing you just said about research being preferred one over the other. I want to broaden up a bit because I see we don't have that much time. One question that was fairly frequently asked was, how do you think about fast AI going forward? Because people are just love your courses and are asking about the potentially the third part of the course. How do you see those two coexisting going into the future?
I'm still trying to figure that out. I think the question is bigger than just like coexisting fast AI and answer.ai, but like to me, my big question is, I mean, obviously on the research side, it's pretty straightforward. The research is just going to be done under a different banner now, so that's fine. So and then software development, same thing. It'll keep happening. Whether it's be that we create a V3 of the fast AI library or we create something else for the same purpose, not quite sure. So I guess the main question then is the courses. And for me, my big question is like, okay, well, what are the courses which need to exist now to help fulfill our mission of making AI more accessible? And I shouldn't say courses, what educational material? Should they still be YouTube videos, or should it be some kind of language model tutor, or should it say some kind of like language model helped study group program, or what? I don't know. And like, what should it be teaching? Because now it's really exciting. We can make things way more accessible than they used to be. Fast AI has always required a year of solid coding experience before you even, as a prerequisite. And in practice, a lot of people with only 1 year of coding experience said they felt maybe that was not enough, and it was a pretty bit of a struggle. Now with like ChatGPT and Copilot and Cursor and stuff, the bar has come down. So my main interest at the moment is thinking about, like, what can we do to make, have like lots more people able to enter this world. So something I've started looking at is creating a new course called How to Solve It with Code. So a lot of you probably come across the book How to Solve It by Polya, which is a classic math book, which describes how to solve math problems from one of our best mathematicians of the 20th century. And I was thinking like, it would be cool to kind of have a similar thing to be like okay, what does code bring to this story? How do you actually solve problems with code? And that doesn't mean you have to write it all yourself, but with code, including letting ChatGPT help you. So that's something that's, that's a course I'm currently thinking about building, and I'm still trying to figure out the best way to deliver a course to get the maximum kind of value out of it, given all the nice resources we have now.
Amazing. Talking about education, I think this is a natural follow-up here, and we talked about this before this call. I know how bullish you are on education, and you're also experimenting even with your own children, which is the same thing I'm going to do, in the sense of like, how do we make sure we utilize the potential that children have? And I always mention the Polgar sister example, where their dad was basically a chess, I think, grandmaster. I might be wrong, but the idea was before they became, like, he decided, I want to make my children great at chess, and he started teaching them when they were very, very young, and they both became world champions. And like in my brain, like what's the chance? Like even you deciding something and then your kid becoming like the best in the world, but what's the chance if both of your children do that same thing? Now, one could make an argument about genes or whatnot, but I honestly think, just from my personal experience as well, that like that early context and having somebody guide you when you're very young is like so powerful. And I believe that the concept of a genius would be debunked for at least many of the feats we've seen throughout history would be treated differently if we knew just how much even an average human could achieve with a special context and care in the youth. So like a bit more open-ended, but how do you think about this? Maybe a question is, do you believe in a concept of a genius? Let me start there.
Yeah, I mean, the Polgar example is great. Not enough people really think deeply about it. Not enough people understand it deeply enough to think deeply about it. I mean, the best of the three sisters, not only was she a grandmaster, but I mean, she was the greatest female ever to play the game by a long, long way. Yeah, so as you say, statistically speaking, this is not at all likely. The third sister, in the end, she was quite, she was by normal standards very good at chess, but she felt like she didn't want to make it her life. That's fine. And she still had a successful life in other areas. And the ones that did get very good at chess seem to have a very nice life. They seem to be happy people, accomplished people. So I think the Polgar example's super interesting. Now that I have an 8-year-old daughter, I definitely see that adults have unreasonably low expectations of children on the whole. And one of the nice things about the internet-enabled world we now live in is that you can just find the small handful of adults who do have high expectations of children. And so that's what we've been doing with our daughter. And so, for example, there's a Yale biochemistry professor who believes that children can do biochemistry. So he's created a program called Biochemistry for Kids. And he told me he told his colleagues at Yale he was going to try to teach primary school children biochemistry all the way up to protein folding. And they all thought he was insane. I didn't know the backstory to all this when I signed up for the course. I just signed up for the course because I thought it sounded like something my daughter would enjoy. It sounded like fun. She had been doing a bit of kind of like particle physicsy kind of stuff at a low level, and kind of she was wondering how this all works when it comes to molecules and whatnot. So it seemed like a good natural next step. And they did, after 24 weeks, they had done protein folding. And along the way, he gave them challenges which I wasn't sure they could do, and my daughter wasn't sure she could do. So, for example, one of them, he said, like, okay, from next week, you're going to need to know the 20 main amino acids. And so here are their formulas, here are their shapes, go learn them. And my daughter's never done anything like that. And, so I printed out the worksheet for it, and she wrote on it, day one, this is impossible. She just wrote that on it. That was her first attempt at dealing with this. And then, we kind of talked about it. We kind of said, like, oh, we could use Anki. We could come up with like mnemonic stories to kind of remember their shapes. We could give them all like characters that we remember. And we talked about, and we're kind of like, well, if we did like 4 a day for 5 days and then an extra day for review, that would be like, so we try to do 4 today. They're like, okay, let's just try to do 4 today. And so we did it together, and we had fun coming up with stories for each, like, this is why this amino acid looks like that, and that one's friends with that amino acid, and, you know, gave them all personalities. And so she got the first 4. And so then the next day she crossed out, this is impossible. And she wrote, this is really hard. I was like, oh my God, it's amazing. And, you know, in the end she did. And the funny thing was, she had them in her Anki. I didn't have it in mine, so I've now forgotten them all. She remembers them all.
Nice.
But, you know, the key thing is here, these kids were, you know, this guy believed that kids can do this, you know, or at least they should be given the chance to do this. And all the kids in the class seem to stick with it, and now they're gone way beyond my understanding of biochem, you know, because it's now another 6 months later, and I have not made any attempt to keep up because I don't know what they're doing. So yeah, I think, you know, one of the things I think really interesting here is, for anybody who's read The Diamond Age by Neil Stephenson, you know, which is about this dynamic AI-enabled book, which taught kids everything from life skills to engineering to math to English to whatever. We're kind of like at that point now where we can have these adaptive educational systems. This is the thing I'm most excited about, because now kids can go at their own speed, you know, and kids can
100%.
find out what they're interested in. I could never go at my daughter's speed normally, because without these kind of systems, I always went too slowly, because I never, like, kids move faster than adults can believe. So I'm very excited about the future of education for kids, and excited to see how much my own daughter is enjoying this.
That's amazing. Like, I just want to make a couple of comments here. First, for the memory bit, like, I think we already have very, very thorough historical records on that. Like, we know that people even back in Rome used techniques like memory palace to memorize literally all the records, like state records, and like we had like people who were actually acting as computers. So like, I think that the memory part is already kind of nicely recorded throughout history. Like, but even the intelligence part, giving something to kids that you would expect only 20 plus years somebody to solve it, who's been doing mathematics for like a decade, I think kids can only pick up that as well when they are young. Because I have a personal example. When I first read this book, I think it's called How to Remember Anything You Want from Tony Buzan. And there is basically this technique how you memorize lists. And this was the first time for me that I've done it. So literally the day before, like my mom basically gave me a list of 100 items. And like the day before I learned the technique, and I could already do it. Like in 5-10 minutes, I memorized 100 items, and she asked me like, hey, number 53, can you tell me what's the item? And I could immediately tell her. And I was surprised by my own memory, because like, even with these simple techniques, you can unlock so much.
Yeah, and anyone can do it.
Anyone can do it. People don't realize that.
Ben Walking with Einstein is a great book to learn about this as well. The other thing I'd say is gamification is fascinating and fantastic. So my daughter and her best friend started playing Factorio, and I gave them the challenge of like, can you finish the game without an adult helping you and without looking up YouTube? And they did. And anybody who's played Factorio knows that's a genuinely challenging game for even a grown-up to complete. But there's nothing fundamentally about it that makes kids worse at it. And so giving them that opportunity, they learnt about, you know, thinking about routing. They learnt thinking about complex logistical systems. They learnt about, you know, various fundamental kind of engineering techniques. It's great, you know. And now we've started playing a game called Stellaris, which is a kind of like a civilization type game, but set in space. And to play that game, you have to think about like politics, and you have to think about factions, and you know, again, you have to kind of think about logistics. And it's amazing, yeah, what you can do with games as well, as to how much stuff kids can learn.
100%. Jeremy, I think you probably have to leave now.
I do, sir.
I think we could literally speak just about this single topic that was the last one we've discussed, like for at least 2+ hours. Yeah, I'm super happy you had the time to join us, and I'm looking forward to potentially coming over the next months as well to just continue these discussions. I think this was super valuable and interesting to me.
Thanks, gang.
Thanks for coming, man. Cheers. Bye, guys.
Thank you for coming. Bye-bye.
Let me stop the recording.